For our next section, we're going to start talking about the set of integers. And in this first video, we're going to do just kind of a broad overview of what the set of integers are and what they look like. So for a definition, it says the integers are the set of whole numbers plus their negative counterparts. Let's really think about that. We have from days gone by that whole numbers, that's the set of numbers that starts at 0 and then increments by 1 from there. So starts at 0, and then each iteration, you're just going to get one bigger. So we go 0, 1, 2, 3. And a lot of times in math, we'll just do this dot, dot, dot. That's called an ellipsis. It just means keep this pattern going. Okay. Now, the integers, if we were to write that as a set of numbers, they happen to go forever in two directions. They don't have like a set starting point or ending point. So you would start with a dot, dot, dot. And then basically in words, we have that the integers are the whole numbers plus all their negative counterparts. So we could say dot, 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 and then we'll start with -3, -2, -1, 0, 1, 2, and 3, and then dot, dot, dot again. And remember that dot, dot, dot just means keep this pattern going. So these numbers go forever in both directions, no fractions, no decimals, just nice, pretty whole numbers, and then their opposites, their negative counterparts, okay? So we do need to make note again that integers do not contain fractions or decimals at all, okay? And 0, when we're looking at the integers, we have positive numbers and we have negative numbers. 0 isn't positive or negative, it's just 0. Now let's look visually at what the integers or the set of integers would be like. So we have this number line right here, okay? So we have this number line, and you can see in the middle we have 0. 0 is not positive, 0 is not negative. But from the left and right of 0, we can see those positive and negative numbers. So to the left of 0, notice we go -1, -2, -3, and so forth. To the right of 0, we go +1, +2, +3, and so forth. So you can see that this number line is labeled. We have our positive numbers going in the right direction from 0, our negative numbers going to the left of 0. And one thing that's really interesting that you need to make sure you understand, because this is going to be really powerful when we start comparing integers, like deciding which one is bigger. From 0, as you go to the right, the numbers are getting bigger. So we have that the values increase in the right side direction. And then from 0, as you go further and further to the left, the numbers are getting smaller. So the values are decreasing in the left side direction. So that's kind of how the integers work. Make sure you understand that there's no decimals, no fractions. 0 isn't positive or negative. It's just 0. And then anything to the right of 0 on a number line would be positive. And as you go further and further to the right, you're getting bigger. Anything to the left of 0 would be considered negative. And the further you get away from 0 to the left, the smaller the number is getting. Okay. Now, one other thing that you will kind of see as we head to the left, we're approaching negative infinity. And as we move to the right, we're approaching positive infinity. So you'll see infinity get thrown around from time to time, not so much now, maybe later as we work through this course, but just know that infinity is not a number, it's more an idea. The idea is there's always something bigger, there's always something smaller, okay? So never say that infinity is like a specific number. It's not a specific number, but it is this idea that there's always something bigger when you're talking positive infinity, there's always something smaller when you're talking negative infinity. So let's look at a couple of examples here. I think we have 1, 2, maybe 3, just 2. So we have 2 examples to look at here. So for example 1, it says find the integer that best represents each scenario. So we just have a few really simple, basic, real-world scenarios, and we're going to represent them with some number that is either positive or negative. So for part A, we have a scuba diver is 20 feet below the surface. A lot of times with little statements like this, we can use just our common sense, like we understand how things in the real world work. But sometimes you can look for like clues, okay? So when you're talking about a scuba diver, imagine the surface of the water being 0. It's not positive, it's not negative, it's just the exact surface, okay? If we go above the surface, that would be positive integers. If we were to go below the surface, that would be a negative integer. So you can kind of envision we've got water, there's a boat. If we go below the surface, we're right here at -20 feet. And this is where our little diver would be, okay? So we would just use -20 And you can generally include a unit. Describe what your answer is. In this case, it's feet. Now for part B, it says the window washer is 40 stories above the ground. So imagine a really intense New York skyscraper. All right. They've got windows, windows, windows. Imagine the ground being zero. The ground isn't positive, it isn't negative, it's just the ground, it's zero. Anything above the ground is a positive integer. Anything below the ground, like if we were to dig under the street, that would be a negative integer. So this window washer is 40 stories above the ground. So this would be positive 40 stories. Now, when it comes to integers, if you're writing a negative integer, you do need to put the negative sign in front of the integer. If you're writing a positive integer, you don't really have to put the positive, it's just kind of understood. So we would just put 40 stories. Now, my sweet angel Winnie has been represented here, and I can feel pretty certain when I did this worksheet, she was probably actually digging holes in my front or backyard. Anyway, part C, my dog Winnie dug a 17-inch deep hole. Well, thank God she hasn't dug one that deep, but I've turned more than one ankle because of her. So imagine the ground. Okay, this is zero. Okay, it's not positive, it's not negative, it's just zero. Okay, and sweet Winnie, we'll put her here. She dug a hole that was 17 inches deep. Okay. Now, generally speaking, when we're talking about distance, distance is always going to be positive. You could say that you go down a distance or you can go up a distance. Generally speaking, distance is positive. But in this case, we're going to say that she dug a hole that was 17 inches deep. So the best integer to represent that would be 17 inches. And we usually use the unit inches in abbreviated form as just IN. So sweet Winnie digging her holes 17 inches deep. Okay. Now, finally, for part D, Sally earned a paycheck of $525. If Sally earned a paycheck, that means she's adding money to her bank account. So if she had nothing in her bank account, that would be zero. Anytime she adds money to it, we would think of that as a positive integer. So again, you don't have to put the positive in front of the 525. The positive is assumed, but you do want to make sure you use a dollar sign. So pretty straightforward. There are gazillions of real world scenarios where we can attach an integer to it. So these are just four really simple examples. All right, example 2, plotting numbers on a number line. This can be really, really helpful at times. Here in just a minute, we're going to talk about absolute value. Understanding a number line can be helpful there. We're also going to talk about comparing integers, and understanding how a number line works can be helpful in that situation as well. So you have this number line. This is kind of how we introduced the idea of integers. We said, hey, there's this number line, zeros in the middle. To the right, we have our positive integers. To the left, we have our negative integers. In order to plot a number on the number line, you just locate that number and then you put a star, a dot, you just darken it somehow, okay? So example 2 says plot the integers on the number line. For part A, we're given 5 very specific integers. We want to plot -10, -2, 0, 5, and 7. So let's start with 0, okay? And I think I'm going to plot these in red, and I'm going to make it a little bit thicker just so we can see what's happening. Okay, so we want to plot 0 on the number line. That would be right there. That's 0, okay? And we can kind of see, think of that not really as home base, but that's just right there in the center. It's neutral. To the right of that is positive, to the left of that is negative. So now let's plot the other 4 integers. So we have -10, that's going to be to the left of 0. We have -2, also to the left of 0. But when you're looking at -10 and -2, it's a little bit weird on the negative side. The closer you are to 0 on the negative side, so to the left of 0, the closer you are to 0, the bigger you are. So in this case, -10 is much smaller than -2. Okay? Now on the positive side, we have 5 and we have 7. So in this case, when you're to the right of 0, the further away from 0 you are, the bigger you are. So make sure you really understand what's bigger, what's smaller, and how this number line works. Okay, now for part B, it says plot the even integers. There's no way we could possibly ever plot every single even integer. There are infinitely many of them. We could start today and go until the very end of the semester and still not plot all of the even integers. So we're just going to plot the even integers that show up on this particular number line. And remember, we've talked about this briefly, I believe, in this class. Even means divisible by 2. So that would mean if you took a number and divided it by 2, you'd get a nice pretty whole number or a nice pretty integer as your result. Okay. Even further, that means the numbers end in 0, 2, 4, 6, or 8. So any number that ends in one of these, 0, 2, 4, 6, or 8, that's going to be an even number. Okay. So for us, that would be 10. Well, -10, -8, -6, -4, -2. Zero's kind of neutral. You could sort of include 0 because it is technically divisible by 2. You take 0, divide it by 2, you're going to get 0. So if you want to put 0 there, that's fine. And then we have 2, 4, 6, 8, and 10. So those are the even integers. Okay, let me fix that so I don't forget to change the thickness later. Okay, so there you have it. That's an introduction to integers. Make sure you really can kind of visualize what integers are via a number line, and make sure you understand how we would apply integers to just really, really basic real world situations.